Hello, everyone. Good morning. I'm Sri Vidya Sampath. I'm going to talk about enabling synchronous replication to achieve high availability using Patroni while running Postgres on Kubernetes. A little about myself. I'm from India. I've been in the US for about 8 years now. I currently live in a quiet little suburb in Massachusetts. I'm a software engineer at Datadog. This is my first time to a Postgres conference and the first time speaking at a Postgres conference. Yeah. And nice meeting all of you. And if I have free time, then I love to read books, try different coffees, cute little coffee shops, and I love to go on hike once in a while. So I mentioned, I work as a software engineer at Datadog. So if you all don't know, Datadog is a observability and a security platform for cloud applications. Our SaaS platform integrates and automates infrastructure monitoring, application performance monitoring, log management, and many more capabilities to provide a unified view, real-time observability, and security for the entire technology stack. So I've divided this talk into 6 different sections. The first section, we'll dive into the architectural components of Postgres while running it on Kubernetes. What is the need for synchronous replication? We tested the impacts of synchronous replication. We'll look into benchmarking, how Patroni behaves in different failure scenarios, how Patroni behaves in different manual operations, what alternative did we consider. Does monitoring require? Do we need monitoring, and if so, what metrics did we monitor, and impact on production systems after enabling synchronous replication? The first section, diving into the architectural components in this diagram. As you see, applications connect to a connection pooler like PG Bouncer or PG Pool. They connect to PG Proxy and connect to Proxy and Proxy routes the connections to the Postgres stateful set. We have 2 different pools, the primary or the leader pool and replica pool. It's a pool because we can have more than 1 instances per pool. In case of primary or a leader pool, we have 1 server that acts as the primary instance that will take the write traffic. And we can have more than 1 standby servers that will act as potential failover candidates. They participate in leader election. They do not serve any read or write traffic. In case of replica pool, we can have more than 1 replica instances, and that will serve only read traffic. They don't participate in leader election, or they don't act as failover candidates. This is because in our architecture, Postgres is a single writer system, so we do not want one instance to overload one instance with heavy write and read workloads. So we have separate service for serving read traffic and write traffic. The primary or the leader server will replicate data to standby and read replica pools. We have Patroni installed on all of the nodes. Patroni is an open source tool that manages and monitors Postgres clusters. All of the nodes talk to Zookeeper, which is a distributed configuration storage that holds the cluster metadata. So all of the nodes talk to Zookeeper in order to know what's the cluster status, who is the current leader, what action to take in case of any failures to keep the cluster healthy and running. So as I mentioned, the active or leader or primary server is a server which accepts the write traffic, DML, DDL traffic. Standby servers, which I'll be mentioning a lot of times in this talk, standby servers do not accept read or write traffic. They only act as potential failover candidates. Replica pool, read replica servers do not accept any write traffic. They only serve read traffic. Read replica servers are not considered as any failover candidates. Did you have a question? So Patroni is an open source tool that manages and monitors Postgres clusters. Some of the use cases are cluster management, periodic health checks and monitoring, leader replication, automatic failover, leader election, high availability, manual and scheduled switchovers. So how Patroni does cluster management? Patroni relies on distributed configuration storage like etcd or Zookeeper. In our case, it's Zookeeper in order to update cluster metadata and manage the cluster. Every time a Patroni node starts, it'll check if there is a leader key on Zookeeper. If there is no leader key, then it starts the leader election process. All of the nodes try to create an ephemeral node on Zookeeper and try to acquire the leader lock. only one node will be able to successfully create this ephemeral node on Zookeeper, acquire the leader log, and thus become the leader of the Postgres cluster. After this, none of the other nodes will be able to acquire this leader log or update the leader key. It's called an ephemeral node because it's a temporary node created on Zookeeper, and the node is active only up until the client session is active. When the leader node goes down, then this ephemeral node with the Zookeeper also gets disconnected. And after a set configuration time period, Zookeeper will just release the leader key. This signals the standby servers that there is no leader in the cluster, so it can participate in leader election. So in this diagram, the primary node loses connection to Zookeeper. The standby node 1 and standby node 2 tries to read the leader key because it checks who is the current leader. Is the leader log still being held by the same node or not? So it tries to read the leader key and it's expired. So it participates in leader election, and standby node 1 and standby node 2 tries to acquire leader log. Standby node 1 acquires the leader log, creates the ephemeral node, and successfully updates the leader key and becomes the new primary. Standby node 2 here is unable to acquire the leader log. It notified that standby node 1 has the signal, so standby node 1 has the leader log, so it stays as standby and starts following the new primary. In certain situations, the previous primary would have there would have been a network partition. So the previous primary would still think that it's still the primary and tries to reconnect as a primary with the Zookeeper. So in this case, it leads to split brain mechanisms. So how Zookeeper handles split brain mechanism is when the previous primary tries to reconnect and tries to acquire the leader log, it'll not be able to acquire the leader log because in Zookeeper, only one node will be able to acquire the leader log, and only one node will be able to update the leader key. That's the current leader. No other nodes will be able to edit this leader key. So with that, yes. No, Zookeeper we have dedicated Zookeeper clusters that will handle the clusters management. Yeah. And once it knows that it's not able to acquire the leader log, then it self-demotes itself, becomes the standby, and then starts following the new primary. So Patroni also updates the cluster metadata on Zookeeper to know what's the cluster status, what's the replication status, and so all of the nodes in the cluster talks to Zookeeper to know what to do in case of any failovers. So with the help of Zookeeper's distributed capabilities, Patroni ensures that Postgres clusters are highly available and consistent. So now what's the need for, we can have more than one standby node. It's always better to have more than one standby node. What's the need for high availability here? Let's take a look at the failover process that happens in Patroni. So when a failure is detected by Patroni on primary node, it'll initiate the failover process. But it won't fail over to a node that's not in a healthy state. It has to pick up a node that has up-to-date data with the leader and it's not in a degraded state. So it does some checks on its end, and one of the check is it checks the maximum lag on failover on standby nodes. So if this lag is under the limit on any of the standby nodes, then it will promote that node to the new primary. But if the lag exceeds the limit on all of the standby nodes, then it will reject the failover. So what is maximum lag on failover? Maximum lag on failover is the maximum bytes a failover may lag to be able to participate in a leader election process. So for example, if maximum lag on failover is set to 10 MB, then Patroni will check what's the lag on all of the standby nodes. If it's greater than 10 MB, then it'll say, oh, I don't find any healthy candidates. I'm not going to perform a failover. At this point, when the primary node is already in a degraded state, then writes will be affected. The cluster might not be in an available state. The leader may not be able to replicate the changes quickly, so it can lead to stale data reads. So can you increase the value of the maximum lag on failover and perform a failover? Yes, it's possible, but that means you're increasing the amount of data loss in case of a failover. So Patroni CTL list will list the current cluster status. So as you can see, the lag in MB is the replication lag that Patroni checks on standby nodes. The no failover tag is for read replicas. We don't want to failover to a read replica, and no sync is we don't want read replicas also to be part of synchronous replication. So section from this takeaways are Patroni monitors and manages Postgres clusters. It uses Zookeeper's reliable distributed capabilities, ensures that Postgres clusters remain highly available and consistent. It checks for replication lag on standby nodes, ensure it will trigger a failover on a healthy node. So when a failover is not possible and the primary node is not in a degraded is in a degraded state, then writes are impacted, cluster may not be available. It can lead to stale data reads and data loss. So how are we going to address this issue? Let's take a look at replication strategies. The primary server, which serves the write traffic, continuously streams the wall ahead logs to all the standby and read replicas. The followers will replay these write ahead logs and apply the changes on their servers. There are two modes of streaming replication. One is synchronous replication and one is asynchronous replication. Asynchronous replication is the default mode of replication. So when client sends a write transaction to the leader, the transaction gets committed on the leader and immediately an acknowledgement is sent to the client. So we don't know if the changes are replicated to a standby. If the changes are flushed to a disk on the standby, we have no information about it. In case of synchronous replication, the client sends write requests to the primary. The primary processes the write transaction and it will wait for an acknowledgement from the standby server to make sure that the changes are also applied on the standby servers. So in this, before sending a transaction commit status to the client. So in this case, it ensures that the data is available in one or more servers. So what's the cost and benefit with asynchronous and synchronous replication? As we saw, in asynchronous replication, there can be data loss during crash or primary node failure. In case of synchronous replication, there's higher level of data consistency. In case of asynchronous replication, there's high transaction throughput and less latency overhead, whereas in synchronous replication, there's less transaction throughput and high rate latency because the primary server has to wait for an acknowledgement from one or more standby servers. So we know that synchronous replication improves durability, but can we use Patroni to enable synchronous replication? Yes, it's possible. There are a few settings that we need to tweak. The first one is synchronous mode. This enables Patroni synchronous replication. If it's set to false, by default, it follows the by default, it's set to false, so it follows the asynchronous replication. Synchronous node count actually manages the number of servers that can be part of synchronous replication. Basically, it updates the synchronous standby names in Postgres configuration. The default value is 1, so it will pick up one standby to be part of synchronous replication. In case of synchronous mode strict, setting this flag to true or false will prevent or make Patroni to switch to asynchronous replication when there are no healthy standbys available. So by default, it's set to false. So when there are no healthy standbys available, Patroni will switch to asynchronous replication. Synchronous standby names. This tells us what servers are part of synchronous replication. If you're using Patroni, then synchronous node count will manage and update this configuration. Synchronous commit. This enables Postgres synchronous replication and has different modes to ensure different levels of durability. We have remote apply, on, local, remote write, off. We'll just see this in a while. So in this image, you can see I used Patroni CTL. I'm using Patroni CTL commands throughout this talk. So Patroni CTL show, once you log into the cluster and you run Patroni CTL show config, it's going to list the current Patroni configurations. If you run Patroni CTL edit config and then add synchronous mode true, synchronous mode strict to true, this is optional, and save the configuration. So in the above setup, synchronous node count will be set to 1 by default, and synchronous commit is on by default. But if you want to change the synchronous commit, then you change it under PostgreSQL.parameters. Once I save the configuration and run Patroni CTL list, as you can see, it picked up one server to be part of synchronous replication. Perf test DB2 here is the synchronous standby. A little bit into synchronous commit modes. So this enables Postgres replication, but it also provides different levels of durability, starting with remote apply. When synchronous commit is set to remote apply, commits are applied on the synchronous standby servers. The changes are flushed to durable storage, and also the changes are readily available for read queries. So up until this point, the synchronous standby server will not send an acknowledgement to the primary server. In case of synchronous commit on, commits will wait until the current synchronous standby servers gets the wall data, applies the changes, and also flushes the changes to a durable storage. As soon as it flushes the changes to durable storage, it sends a commit status to the transaction commit status to the primary server. In case of remote write, commits will wait on synchronous standby servers. Commits will get applied on synchronous standby servers on the file system, and it will not ensure that the changes are sent to durable storage or not. So remote apply and on provides the highest durability because it ensures that the data is flushed to durable storage. And local and off, in case of local, the transaction wait for acknowledgement from the local servers, and for off, it does not wait for any acknowledgement. It doesn't ensure that the changes are flushed to durable storage in the local server also. So as different synchronous commits provide different durability, it will also impact the write latency. So the higher the durability, then the higher the write latency also. Synchronous standby name specifies a list of standby servers that can support synchronous replication. In this talk, I'll use only priority-based replication. Patroni also supports quorum-based replication. So if you set synchronous node count to 2, you can see it picked up 2 nodes, perf test db1 and perf test db2, and it also assigned a state priority to both the nodes. So perf test db1 is a synchronous standby with priority 1, and perf test db2 is a synchronous standby with priority 2. The failover or switchover will happen to the node with the highest priority, but if one of the node goes down, then automatically Patroni will update the priority of the healthy node to the highest priority. Yes?
I'm sorry, you said earlier that priority is given to the one with the least maximum lag on failover. Like it's looking at how far behind it is.
Yes.
It chooses, but then here you're saying it's priority. So which is it?
So it'll set with priority 1 and 2, but in case if synchronous node count is set to 2, but in case if there is a lag on one of the standby nodes, then it'll pick up the node whichever has the, it'll change the priority of the synchronous node to the highest priority. So in case if perf test db1 has lag, then it'll automatically change the priority of perf test db2 to be 1.
So it takes priority really on the lag. That's really what it's looking at. It'll look there.
Yes.
If the lag is the same, then it'll go with priority.
Yes.
But if the lag is behind on more than one, then it will ignore priority and go with lag.
Yeah.
Okay, got it. Thank you.
So yes, can we revert to asynchronous replication? Yes, it's possible. When you run Patroni CTL edit config and just change synchronous mode to true and false, it's good. Synchronous mode from true to false, it's going to update to asynchronous replication. There's no restarts or no downtime required in this case. So now we know that synchronous replication is going to affect write latency. We wanted to do some benchmarking to understand what the impact would be with different synchronous commit modes, what commit mode, synchronous commit mode will be appropriate for us. So we used pgbench, a benchmarking tool for Postgres, to test the performance of the database by simulating traffic. We used TPC B-Suite, and this benchmark measured latency average and transaction per second. In the benchmarking calculation, so we took average values of latency and TPS for every synchronous commit mode. We used the same instances for all the tests. We ran tests with like different scale factors, different number of clients, threads, and transactions, and we compared it with the asynchronous replications, average latency, and TPS. This was our numbers. So this based on the level, it's ordered based on the levels of durability each synchronous commit mode provides. So as you can see, remote apply being the highest providing the highest durability, it also had like the highest increase in latency, which was like 41% compared to synchronous commit on, and compared to synchronous commit remote write, which had 31% and local at 26%. There was also a reduction in TPS. There was 34% in reduction TPS for remote apply, and 31% reduction in TPS for synchronous commit on. To remote write had 27% and local had 23%. This is also a graph that shows a nice trend with the level of durability. So remote apply, as the durability decreases, the latency also decreases. So the performance would be high. And with the TPS, as you see, with different durabilities, the TPS, the transactions throughput also increases. The performance will also increase. Yes. It's in different zones, availability zones, yeah, but the same region, yeah. So the takeaways from benchmarking, performance impacts, the highest performance impact in terms of latency and TPS was for remote apply, followed by on, and followed by remote write, followed by local, and followed by on async. When using asynchronous replication, remote apply and on provides the highest durability. The difference in latency and TPS between remote apply and on was like about 5 to 7%. So based on which instance we want the synchronous replication to be enabled, and based on the highest durability that we want, we can choose the appropriate settings, which would be remote apply or on. So now we know how what the impact would be on write latency or TPS. We also wanted to know how Patroni will act in case of failures, in case of server crash or a resource contention. So we can look into like what Patroni will do in case of synchronous standby server crash. All standby servers crash, standby and read replica servers crash, zookeeper failure, primary or leader server while waiting for an acknowledgement from a synchronous standby. So this is the initial Patroni configuration. I said synchronous commit to remote apply. Synchronous mode is set to true. Synchronous mode strict is set to true. So default value synchronous node count is 1, which means one node would be a synchronous standby node. This is the initial cluster status. The cluster is in a healthy state. Perf test db2 is the sync standby. So I went ahead and I stopped the wall receiver on synchronous node, perf test db2, and then I ran a bunch of inserts and update commands. So perf test db2 accumulated enough lag. So what Patroni did was it detected that perf test db2 is not in a great state. It has enough lag. So within few seconds, it promoted the next healthy standby to be a sync standby, which is perf test db0. So if you look at the logs, it says synchronous standby status assigned to perf test db0. So it promoted the next healthy node. It automatically detected the issue and promoted the next healthy standby node to be a sync standby. So what happens when all standby servers crash? This is dependent on the synchronous mode strict flag. So when synchronous mode strict is set to false, this will make Patroni to switch to asynchronous replication when there are no healthy standbys available. So I ran Patroni ctl edit config. I changed synchronous mode strict from true to false, and I applied the configuration. So I also stopped both the standbys, perf test db0 and perf test db1, so there are no standbys available. So what Patroni did was it removed the synchronous standby name configuration from Postgres configuration file. So in the logs, if you see, it says parameter synchronous standby names removed from configuration file, reset to default. So when I did show synchronous standby names, it doesn't have anything in the entry, it switched to asynchronous replication. So when synchronous mode strict is set to false, and when there are no healthy standbys available, then Patroni will switch to asynchronous replication.
What's going to happen to the current transaction that's waiting for commit on the replica?
It should get all the data. It should make sure that all the data persists, and then it should switch to asynchronous replication. Yeah. In case of synchronous mode, strict is set to true. Setting this flag to true prevents Patroni from switching to asynchronous replication when there are no standbys available. So I changed synchronous mode strict from false to true. I applied the configuration. I stopped the standbys, perf test db0 and 1. And perf test db replica A, perf test db replica G are like read replicas. In this case, Patroni sets synchronous standby status or synchronous standby names to star because in this case, it doesn't want to adversely affect the writes or adversely affect the applications by stopping the writes. So it will pick up one of the potential candidates and make it a synchronous standby. So when you run Patroni CTL list, you will not see any dedicated sync standby, but Patroni will just choose one of the potential candidates. All of the followers are considered a potential candidate, and whichever are not tagged as no sync true would be part of synchronous replication. But when there are no healthy standbys available, it will pick up one of the potential candidates and make it a synchronous standby, and it will ensure that the writes are not stopped. So what happens when all standbys, including the read replicas, crash? So in this, when all the standbys and all the read replicas crash, there are no followers. In case of synchronous mode strict is enforced to true, then the primary server has to wait for an acknowledgement from one of the followers. So since all the followers are unavailable, then the writes are stopped at this point. This ensures that the data persists at least in one or more servers. So that's the reason why the writes are stopped when there are no followers. So even if one of the potential candidate comes back up, it will immediately switch synchronous standby names to star. And if one of the server that can be part of synchronous replication comes back up, then it will change the synchronous standby name to it will assign the synchronous standby name to that particular standby server. So the next instance was Zookeeper failure. Yeah. It will stop accepting the writes. Yeah, so that's what I did. I tried to run a bunch of insert commands on the primary, and then it just didn't accept any of the writes. Yep. Yep. In case of Zookeeper failure, so yeah, in this case also writes is stopped because I tried to connect to I scaled down all the Zookeeper pods, then I tried to connect to the cluster, run Patroni commands, but it just said socket connection error, operation not permitted because Patroni at this point doesn't know how to do cluster coordination. Connection to the cluster is not possible, and I also tried to run I also tried to send some writes to the primary server, but even that did not succeed, so writes are also stopped. What happens when primary instance crashes while waiting for an acknowledgement? So at this point, there was in the logs you see it said that canceling the wait for synchronous replication, and it terminated the connection. So the waiting transactions will be marked fully committed only when the primary database recovers. In this case, it stops. It ends. It says that it will cancel the wait for synchronous replication, but Postgres guarantees that the application will also not receive any explicit acknowledgement that the transaction has been committed until the wall changes are applied also on the synchronous standby servers. So takeaways from failure mode testing, in terms of server crash, Patroni quickly and automatically detects the failure and chooses the best strategy to resolve the issue. When there are no healthy standbys or synchronous standbys available, Patroni will try to not adversely affect the applications. Based on the synchronous mode strict flag is set, it will choose the best path forward. So does Patroni provide us safety rails with manual switchovers and failovers? Will we be able to switch over to an asynchronous or failover to an asynchronous node? Yeah, so I ran a Patroni CTL failover. It gave me a list of candidates to choose from. I chose perf test db2, which is the asynchronous node. It asked me, are you sure you want to failover to an asynchronous node? I said yes, and it aborted the failover. So you won't be able to failover to an asynchronous node when a sync standby is available. Failing over to synchronous standby node, that's possible. Patroni CTL failover. I chose perf-testdb0, which is the current sync standby, and then it asked if I want to do the failover, demoting the current leader, yes, and it successfully failed over, promoting perf-testdb0 to be the leader. Can I do a force failover to an asynchronous node? Yes, that's possible. So when I ran Patroni CTL failover force candidate and I chose the asynchronous standby node, it successfully failed over to perf testdb2. So in case of failovers, a force failover is possible to an asynchronous node. So what happens in case of switchovers? I ran Patroni CTL switchover, so gave me a list of candidates to choose from. You can also do a scheduled switchover, but I chose to do the switchover at that point. So are you sure you want to switch over cluster to demoting the current leader? Yes. So it threw me an error saying candidate name does not match with the sync standby. Unlike failover, in force switchover, you won't be able to do a switchover to to an async standby. So I ran Patroni CTL switchover, force candidate, asynchronous standby node. Even in this case, it said candidate name does not match with the sync standby. But if you run just Patroni CTL switchover or Patroni CTL switchover force, it will automatically choose the current sync standby and perform the switchover. So failover to an asynchronous standby node is possible, but you can do a force failover. In case of switchovers, you cannot switch over to you cannot do a force switchover or a switchover to an async node when a sync standby is available. But when you run just a switchover without any candidate, it will automatically choose a sync standby for you. So we know how Patroni does cluster management, what the impact would be in synchronous replication, how to enable synchronous replication, what would be how it works with different failure scenarios. Did we consider any other alternatives? Yes, we considered distributed replicated block device, which is a block replication. Block replication, also called disk mirroring, mirrors the contents of one server storage to another. So when there is a wall change detected, it's going to copy the entire directory, including data files and wall files, from one server to another. It might have lesser latency compared to streaming replication because this happens at the block level and the changes are applied almost instantly. But it required a large architectural changes to incorporate DRBD, and also it doesn't provide a way to set up synchronous compensation like on a per transaction basis or a per session basis. So yeah, we did not go with DRBD and we went ahead with Patroni. We can have third-party providers that helps with DRBD. But it's implemented by Linux, but you can have third-party providers that can help you with implementing DRBD for you. Yep. So what were the challenges that we faced during deployment? Main challenge we faced was, yes, planning and deployment because testing does not mimic production. We want to know what the effects of synchronous replication would be on our production clusters with different traffic peaks, traffic volumes, vacuums, auto vacuums, data backfills, batch jobs. So under different scenarios, we wanted to make sure that the synchronous replication does not adversely affect the applications. We are not increasing the latency high enough that the writes are slow. So we wanted to do a very controlled and slow rollout, understand what the impacts, what are the current metrics would be, see what failures that we can face in terms of resource contentions and scale ups and stuff. Because when you're scaling up, when you scale up a primary, you also have to scale up a synchronous standby just so that it can process the writes at the same rate. So we wanted to do a slow and controlled rollout. That was pretty challenging part, but yeah, overall it was smooth. So synchronous replication ensures durability. Yes, it ensures that the data is stored in one or more servers. Patroni does automatically checks the cluster status. It does automatic failovers. So do we need to monitor? Is monitoring required? Yes, monitoring is always required. It's healthy. So one thing that we need to monitor for synchronous replication is the sync rep wait event. This wait event occurs when the primary server starts waiting for a confirmation or acknowledgement from a standby server. And the synchronous replication wait event ends once it receives the acknowledgement. So if the synchronous standby servers are overloaded or is unable to apply the changes from the primary, then that's the synchronous replication wait event is going to increase. It's going to increase the write latency and will adversely affect the applications. So we want to know what's happening with sync rep wait events, and we want to know what queries are causing this, what's happening behind the scene. So that's one good metric to monitor on. The second one is monitoring for no synchronous standby nodes. Based on the synchronous mode strict flag, it can switch to asynchronous replication, or it can choose a potential candidate, but we don't want a cluster not to have a dedicated sync standby for a long time. In this graph, you see like Patroni immediately switches from one sync standby to another, but we wanted to know if for a long time there is no sync standby available. This is in addition to this, we also have our Datadog database monitoring tool, which gives us an exhaustive view of like what's happening in the cluster. It tells us like what queries are waiting on what events, what are the blocking queries, what services are calling what queries, and like for the active connections, configurations like different auto vacuum settings, different replication settings. It also gives us like explain plans, so it's easier for us to figure out what's happening in the cluster, what queries are causing issues, and fix the issues. So moving on to the last section, what was the impact on our production systems? So even with the highest durability, we did not see any significant impact in latency for our services. This was the time, like the red line shows the time we actually enable synchronous replication. There was just a slight increase in our inserts or like in our update queries, but we did not see any significant impact on latencies for services or query times on Postgres side. Read queries are not part of synchronous replication, but even otherwise, we did not see any impact on the read latencies.
Are you running these back to a connection pooler or direct to the database?
This is through the connection pooler. Yep.
So this is taking into account network latency,
Yeah.
response time, and volume.
Yes. Yeah. Which is stored in Kubernetes, but yeah, I'm just talking about the VMs. Yeah. This is just on Kubernetes, if you know. Oh yeah, you're talking about like if it's a node or like if it's on Kubernetes. Oh, it's all on Kubernetes. Yeah. Yes. So yeah, the final takeaway is synchronous replication improves durability. It makes the cluster be highly available, but impacts write latency and transaction throughput. When using synchronous replication, remote apply and on provides the highest durability because it ensures that the data is stored on the durable storage, even on the synchronous standby servers. Patroni, as you saw, like in different crashes or like failure scenarios, it enhances high availability by automating cluster management, failover, and replication processes. It chooses the best strategy to resolve any issues. We have resilient and self-healing deployments that requires minimal manual interventions. It also provides key metrics that we can use to monitor cluster health and get alerted in case of any issues. So yeah, that concludes my talk, and let me know if you have any questions. Thank you. Yes.
I actually have several questions. So first, regarding that release of
Yep.
do you have a blog or some post where y'all put out where y'all done all this to show?
No, so far no, but I'd be happy to put up a blog if it's helpful. Yes. Yeah, I can, yes.
So how long till failover completed? Like when Patroni recognized that a failover needed to happen, how long did it take for it to execute?
So it's about 30 to 45 seconds. I think there is a loop wait that it waits up until a certain time. There's a loop wait in it for when I did a lot of testing, it was about 30 to 45 seconds.
You also have to wait for the replicas to resynchronous in primary.
Yeah.
When you leave it,
But
that takes much longer.
But it's almost instantly available for most of the times. We never ran into an issue where only when like all the followers or like all the standby servers are in a degraded states, it takes time. But otherwise, most of the times when we tested, it took about 30 to 45 seconds. I think yes. Yeah. Yeah. Yeah.
It is
Yep.
configurable? That's good.
You don't want to set it too short because then you start getting
Exactly.
failover. You look at the timeline that she had. She was either testing or she had problems with her configuration because she had 135
Yeah.
pipelines in there. So
Yes. Yes. Yeah. I did. Yeah. I think about 170. Yeah. This was like 134.
yeah,
But
I was
yeah.
close.
Yes.
Setting maximum log on failover.
That's configurable too.
Yeah. So is that only something that shows up on the replicas, or does that show up on the primary? I mean, it would make sense, but does it actually show up on for primary?
Um, I think it doesn't show up.
Okay.
Yeah.
So server indicated as a leader would not have that
Yeah.
available to it. Okay. Yeah, because that question led into what if a leader dropped off, a new one's selected, and then when the leader wants to come back, guess what? That new one dropped off too. And now that leader's grabbed, the old leader has grabbed and said, "Oh hey, I'm on," but he's way far behind.
Yep. Yeah. It's possible,
So
but
if that old leader never had that maximum lag on failover, then it would add that to your system. Okay. And when you're waiting for a response on standby in synchronous, how long does it wait? Or it just says, I don't know, do some, I'm waiting.
I think there is a parameter which I'm not sure about, but I don't have, yeah, I'm not sure about the exact parameter name, but there is a time that you can set that is default, or you can set it. And it'll wait up until that point, and if it passes that point, it'll just say like, oh, I won't be able to wait it. Yeah.
Yeah.
I think it says synchronous standby lag or something. I'm not exactly sure about the parameter, but yeah, there's definitely a parameter for that. Yeah.
I noticed at the beginning of your presentation you were saying standby only or standby read replica,
Yeah.
and you wouldn't use failover to standby read. Why not failover to standby read replicas?
We just wanted always read replica to serve only read traffic because of the user managements and access controls and everything. We don't want read replicas to have to fail over to read
Your
replicas.
presentation, you led me, well, I'm using standby read replicas for my failovers, but it came across as it's not going to work.
Oh no, no, it's just in our architecture that we don't want to. Yeah, it's a preference. Yeah.
You might want to clarify
Oh
that.
yes, yes. It's just a preference of choosing not choosing the read replicas. Yes.
I think it's also important to emphasize that if you do have a very write-intensive workload, it's going to suck, like you mentioned.
Yes.
Just emphasize.
Yeah. Awesome. Thank you very much. Yep.
One last question.
Yeah. Sure.
In the situation where you indicated where the synchronous standbys are not available, so then it has to go to one of the read replicas, right?
Yep.
But they still look at those. Is that configurable to say, I don't want you to use my read replicas at all?
It's not possible because in this one, if you see, it's set to no sync true and no sync. Both the read replicas are set to no sync true. They are not part of synchronous replication, but still, according to Patroni, they are considered as potential candidates. So if there's nothing, like if there are no standbys available, which or servers that can be part of synchronous replication available, it will still go ahead and choose one of the follower, just to make sure that the leader can process the writes and also ensure that the data is durably stored on the follower too. Any other questions? Awesome. Thank you. Oh, yes. We're using the Postgres operator. I think we're using Spilo, Patroni. Yep.
We've got I work with Persona. We have the Persona Postgres operators, which is pretty solid right now. So give that a try sometime. It's pretty,
The Postgres operators?
yeah,
Oh, yeah, sure.
Persona.
Percona. Okay. I think we did look into it initially, but I don't know. I was not involved in that. But yeah, I'll take a look at it. Yep.
It's a fork of the Crunchy data.
Sure. Oh, okay. Crunchy data. Okay, got it. Yeah, yeah, yeah. Makes sense. Yep. Yeah.
So I know Kubernetes has been around for a while. I just personally don't have any experience with it. Can you just give like a quick overview of what it does and what's the how does it work with Postgres?
So you're asking like how Postgres will work in Kubernetes?
Yeah.
So yeah.
All I know is that there's something about containerization
Yeah, so I don't know if you were there for this. So we basically, yeah, we do have um, like Postgres stateful set pods, proxy pods that access like TCP proxies, and then we have the Postgres pods that will also have the Patroni process running in the same, yeah, both Postgres and like Patroni running on the same nodes. We have like dedicated Zookeeper clusters that will manage the Postgres clusters. So you can, and yeah, the standby servers, it's good to have more than one standby servers just in case if one of the standby server goes down. Yeah, I'm just taking questions. Yeah, thanks. So, yeah.
Your proxy, are you using HA proxy or are you using the Kubernetes proxying service?
Oh no, we have HA proxy. We also have like Envoy proxy.
So we're getting away from HA proxy because of third-party tools. Now with libpq,
Mhm.
the connection strings are so much better with the session attributes than having to use HA proxy.
And
You use a URI, regular TCP connection string, and
oh,
it does
nice.
everything.
Okay.
Especially with load balance feature in it as well. So
Oh, nice. We have like connection pooler and like it's either HA proxy or Envoy proxy that we use for load balancing and sending
another
functions.
layer
But
for
yeah,
management.
there's like a lot of network hops that's happening with like multiple load balancers in this one. Um, It depends on the cluster, I guess. So if it's like a smaller cluster, you don't have to have like so many replicas. It's always good to have like 2 standby servers at least. But in case of read replicas, it depends on like the application workload. You can use like 1 or 2 replicas, so that should be enough. Sometimes there are clusters where there are no read replicas, but it's always better to have just so that you have the user control, access management, all of this like separated. So it's if you have like a lot of replicas, and I understand like it'll be a little difficult during like major version upgrades or things like that. But so far, I think it's been a good thing having multiple read replicas and having like
Yeah, PG in-place upgrade is a real pain with Patroni. So upgrade
Oh,
over
that's a
here
good
to
thing.
do the in-place upgrade without downtime, but you have to be able to, you can't have, if you're Dockerizing or if you have your container running, you can't have it detach and fail. So if you ask about upgrade, it's not as straightforward as just running a PG upgrade to an existing replica in the order necessary.
Oh, I've not tried major version upgrade with Patroni. So you're saying like you have to take all the replicas down and then okay. Oh, okay, that makes sense. Yeah. Patroni talks to Zookeeper. In proxy, it's just the applications connect to connection pooler and sends to the proxy for. Yeah. Yes. It goes to the Patroni process. It doesn't go to Zookeeper. Yeah.
Thank you.
Thank you very much.